3.1, solving right triangles. So a couple things just to review. Sohcahtoa. We can use sine, cos, and tan when we have a right triangle. Okay? Um, you should know these off by heart. So sine is opposite over hypotenuse. So if we're looking at sine of A, opposite and hypotenuse, so that's A over C. And I trust that you guys know this stuff. As well, whenever we use a right triangle, we have Pythagoras. We can say A squared plus B squared equals C squared. The only important side is that C must be a hypotenuse. Okay, so for example, if I needed to solve this triangle, the word solve means all angles and all sides. We need to solve it if C is 90, so it's a right triangle, and we know angle B is 35 and side B is 7.24. Just a reminder, this is called side B because it's opposite angle B. So just some stuff to remember about triangles there. Okay, so first of all, I know angle A. I can say angle A is 180 minus 90 minus B. This was 55. Okay, 35 rather. So then A must be 55 degrees. Okay, and now I can do these angles. Let's look at this angle right here. I know the opposite. I don't know the hypotenuse. So opposite and hypotenuse is sine. So I could say sine of 35 is equal to 7.24 over C. Solving for C, I cross multiply. So I get C sine 35 is equal to 7.24. I divide both sides. I get C is equal to 12.62. Careful. Your calculator should now be in degrees because this is in degrees. So just be warned, if it's still in radians, you're going to get some funky answers. Okay, I also could have used other angles and ratios here, okay? This isn't the only way to find C. So I said side C is 12.62. So now I could use Pythagoras or I could use another trig ratio. I'm going to use the trig ratio here. Well, I'm going to say the tangent of 35 is equal to Sohcahtoa opposite over adjacent is 7.24 over A. Following the same pattern, I'm going to get my A to be 10.34. Just a note, it's always best to use angles and sides that you are given rather than ones that you have derived. Just in case you make a mistake, you don't want to make a mistake and then use that in every calculation after that. So always use the ones you're given if you can. Just a review about angle of elevation and angle of depression. So if we're talking about angle of depression, we go from our horizon, and angle of depression is measured down from that. Angle of elevation is upwards. So here's an example of a problem that uses this. If a pilot of a plane is flying at a height of 2 kilometers and notices that the angle of depression of the runway is 22.5, what is the pilot's ground distance from the near end of the runway? Okay, so angle of depression is measured this way. And now because we can create a triangle. We said we're 2 kilometers from the ground. This is a right angle. This is also a right angle. So I can figure out what angle is missing right here. And that angle is going to be 67.5. What I did is I said 90 minus 22.5. And what I really want to know is this right here. I'm going to call that x. So I have an angle. I want to know the opposite, and I know the adjacent. So I can say tan 67.5 is equal to x over 2. Solving for that, I can find that x is equal to 4.83. My units are kilometers. Okay. In this chapter, it's not going to be simple right triangles. They're going to use compasses. So just north, south, east, west, you should know. Halfway between North and northwest is called north and west is called northwest, and halfway between that is north northwest. So for instance, if I put something here halfway between northeast and east, it'd be northeast east. We don't see that much anymore, but just in case somebody does say that. Okay? Next up, line of travel. So if in a problem, if they say line of travel, it's the degree measured in a clockwise manner, and a clockwise goes this way. So if they said they have a line of travel of 200 degrees, you start from due north, and then you go 200 degrees clockwise. Similarly, 315 degrees would be clockwise from due north. Um, as well, sometimes they can be given in this form as well, where we say we go north 25 degrees east. So that means you start at north, you rotate 25 degrees towards east, so 25 degrees. And what's interesting here is you get some nice reference angles. So this is the same as having 65 degrees there, because 65 plus 25 is equal to 90. Similarly, this measurement is north 62 degrees west. That is the same as 28 degrees here. So in other words, that could be the same as west 28 degrees north. Those are equivalent. Those are really talking about the same direction. So just be aware of that. Okay, so we have one last problem. A boat leaves harbor. This is an American harbor. You can tell by its spelling. And sails 225 kilometers on a course south 52 degrees west. So what I would always do is I'd always draw a north, south, east, west axis. And I'd say, okay, this is my harbor. Um, and it's going south 52 degrees west. So here's south, but it's going 52 degrees towards the west. So it's really forming this. And what it says, it travels 225. And what we want to know is how far south is it. So we're going to make a nice little right triangle here. And what I'm really trying to find is right there. So this is 52 degrees. So I have an angle. I know the adjacent and the hypotenuse. So I'm going to use cos is equal to x over cos of 52 rather is equal to x over 225, and I'm going to solve for that by cross multiplying, and I'm going to get x is equal to 138.24. My units were kilometers.